Hello everyone, stop doom scrolling and start counting the longest subarray with sum k. Okay, so we'll use a HashMap plus prefix sum approach for this question. And now question is why? Why do we not use a sliding window? The first thing when you think of subarray is a sliding window. Why does sliding window not work over here? Simple, we have negative numbers. So you would never know when to slide the ith pointer because the negative number can come at any time. With sorting, same thing. You can't sort, it's a subarray, so you can't change the sequence. That's why you can't use a sliding window, and hence the question is a HashMap plus a prefix sum approach. Now, how we'll do it? Let's do a dry run. Now, what we'll do at each step of the for loop is we'll count the prefix sum, the p sum over here, at the ith index. We'll check if map of sum minus k already exists. If it exists, then we can check the subarray with the longest sum. Also, if the sum prefix sum is directly equal to the answer k, then also. Now, the question is why do we do if statement? Okay, imagine instead of this 10, there was a number 2 behind it. Okay, so in the start the sum would be 2, then it would be 12, then it would be 17. Now when the sum is 17, this subarray in itself had a sum 2 and this total subarray had a sum 17. Now we need to find sum 15. So if we check if 17 minus 15 already exists, that means there must be a subarray with sum 2, and if it exists in the map, that means this subarray over here must give the answer 15, and hence you will check what is the length of this subarray and update the answer accordingly for the longest subarray. That is the intuition behind this if statement. Okay, now I'll just remove this and we'll go back to our original example. This is 10. So at the start I is at 10 and the prefix sum is 10 with I equal to 0, and the sum minus k is equal to minus 5, and the answer is currently 0. Okay, next we move to 15. 15 at I equals to 1. Now 15 is directly equal to k, and we can just do an answer is equal to maximum answer comma I plus 1, because the number of elements till now is going to be the index plus 1. All right, then we move ahead. We have 17 and we check, does 2 exist in the map? No, it does not. So answer remains 2. We go to 24. Does 9 exist in the map? It does not. So answer would remain 2. I'm not sure why I've written 4. Answer remains 2. Then we go to 25. We check, does 25 minus k, which is equal to 10, does 10 exist in a map? Oh, it does. 10 exists with a subarray at I equal to 0. Okay, so this is what we have stored in the map, the amount of prefix sum and at what index of the subarray was that prefix sum found. So now to find this, we'll directly do the current index minus map of this number. So current index minus map of this number, which is 0. So 4, I is at 4 right now. 4 minus 0 is equal to 4. Hence that is the answer. So guys, that is the approach behind this question. And simply for next, we'll go k equal to, I equal to 5, which is equal to the prefix sum is equal to 15 once again. So we'll directly do I plus 1, the number of elements. So directly do an I plus 1, so 5 plus 1 is equal to 6. So the answer is maximum of 6 and 4, which is equal to 6. So guys, that is the approach behind this question. The simple HashMap plus prefix sum. Now for the time complexity and space complexity. Time complexity of this question is big O of n, and the space complexity of this question is also big O of n for the HashMap. So guys, this is it for this video. Meet you in the next one.